Hello everyone. Have you ever noticed why some electrical appliances heat up when current flows through them? Or why long electric wires get warm after being used for a long time? The answer lies in an important electrical property called resistance. Today, we will understand what resistance is, its definition, formula, units, factors affecting it, and its importance in electricity. So let's begin. Introduction to resistance. Electricity flows through conductors like copper wires to power our homes and devices. However, the flow of electric current is not always smooth. Materials oppose the flow of current to some extent. This opposition to the flow of electric current is known as resistance. Resistance plays a crucial role in controlling current, protecting devices, and converting electrical energy into useful forms like heat and light. Definition of resistance. Resistance is the property of a conductor that opposes the flow of electric current through it. In simple words, resistance decides how easily or how difficult it is for electric current to pass through a material. Low resistance, more current flows. High resistance, less current flows. Relation between resistance, voltage, and current. The relationship between resistance, voltage, and current is given by Ohm's law. According to Ohm's law, the current flowing through a conductor is directly proportional to the potential difference across it, provided temperature remains constant. Mathematically, V equals IR, where V equals voltage, I equals current, R equals resistance. From this, resistance is given by R equals V by I. SI unit of resistance. The SI unit of resistance is the ohm symbol. 1 ohm is defined as the resistance of a conductor when a potential difference of 1 volt produces a current of 1 ampere. Nature of resistance. Resistance is a scalar quantity, meaning it has magnitude but no direction. It depends on the properties of the material and the physical dimensions of the conductor. Factors affecting resistance. Resistance depends on several factors. Length of the conductor. Resistance is directly proportional to the length of the conductor. Longer wires have more resistance. Are directly proportional to L. Area of cross-section. Resistance is inversely proportional to the area of cross-section. Thicker wires have less resistance. Are directly proportional to 1 by A. Nature of material. Different materials have different resistances. Metals like copper and silver have low resistance. Insulators like rubber and plastic have very high resistance. Temperature for most conductors. Resistance increases with increase in temperature. For semiconductors, resistance decreases with increase in temperature. Formula for resistance of a conductor. The resistance of a uniform conductor is given by R equals pi into L by A, where pi equals resistivity of the material, L equals length of the conductor, A equals area of cross-section. Resistivity. Resistivity is a material property that indicates how strongly a material resists electric current. SI unit of resistivity. Ohm meter, omega m. Lower resistivity, better conductor. Resistivity depends only on the material and temperature, not on the shape or size. Types of resistors. Fixed resistors have a fixed resistance value and are commonly used in circuits. Variable resistors. Their resistance can be changed. Examples: rheostat potentiometer. Heating effect of resistance. When current flows through a resistor, electrical energy is converted into heat energy. This is called the heating effect of electric current. This effect is used in electric heaters, electric irons, toasters, electric kettles. Resistance in series and parallel circuit. Series combination. Total resistance increases. R total equals R1 plus R2 plus R3. Parallel combination. Total resistance decreases. 1 by R total equals 1 by R1 plus 1 by R2 plus 1 by R3. Importance of resistance. Resistance is important because it controls the flow of current, it protects devices from excess current, it helps convert electrical energy into heat, it is essential in designing electrical circuits. Applications of resistance. Resistance is used in electrical appliances, electronic circuits, voltage dividers, current control devices, safety fuses. Summary and conclusion. To summarize, resistance opposes Current flow SI unit is ohm. It depends on length, area, material, and temperature. Ohm's law explains resistance. Resistance is essential for safe and efficient electrical systems. Understanding resistance is key to understanding electricity. Call to action. If this lecture helped you understand resistance clearly, backhand index pointing right, like the video. Backhand index pointing right, share it with your friends. Backhand index pointing right, subscribe to the channel for more easy and concept-based physics lectures. See you in the next video. Keep learning and stay curious. 高压电标制火箭